Okay, so the first one, I'll do A. Now, you saw the definition there. Guys, listen. It's good if you can remember the definition from the book. But if you don't remember the definition, what can you do in the exam? Well, this is what I would do in the exam. For part A, write down the formula. What is the formula? Q equals CV. And what do they want? They want C is Q over V.
So define the formula.
So you could define the formula, but they want it in words. So very good. Quantity of charge per unit volt.
Can I use the word ratio of charge?
You could, but I don't like it. I prefer per. So you can say capacitance is the amount of charge per change in voltage. But there's a better word than voltage. Potential difference. So you could say capacitance is the amount of charge required for the per change in potential difference. Whoops. So capacitance. Okay. Capacitance is the what did I say? Charge, isn't it?
Yeah, amount of charge.
Is, I know. Undo. I'll change it. Is how.
Is that
No, I was going to say how much. No. Capacitance is the charge needed. No, I didn't say need, I said required. That's a better word. Required per unit change in potential difference, or PD for short is acceptable. PD means voltage. It's a little trick for the exam, okay? So for example, if you had a formula like this, Z equals X over Y, you could say, well, Z is the X required per unit change in Y. It's like a template. Okay? And that's useful because the formula is in the formula book. So as long as you know how to put that sentence around the formula, you'll be fine. Now let's compare it with what's in the marking scheme. Capacitance is the charge required to cause a unit charge in potential of a conductor. It's pretty much the same. How many marks is that now? 2 marks. So I would say 1 mark for this and 1 mark for this would do it.
Do you have to write the formula?
Oh, always. If you ever... Okay, if your question is, should I write the formula, the answer is always yes. So every time you want to ask your teacher, I wish I could ask Stephen, should I write this formula? He is sitting beside you in the exam and he turns to you and says, yes, no, you should write the formula every time. No exception. Okay? Well, not just no. You can all imagine me beside you. Alright, let's go on to the next one. Right, so that is the capacitor, that is the voltage, what is the charge, what is the energy? Okay, so B part. Can you give me the information? What did we know?
Potential difference.
We know the voltage is what? 40. And what else do we know? The capacitance is 8.5 microfarads. And what do they want first?
They want the charge.
So what's the formula?
Q equals CV.
You know how to multiply? Of course you do. So multiply these two. 40 times 8.5 times 10 to the minus 6. Now, if you don't do this, then your answer is in micro. So anyways, what do you get here?
3.4 by 10 to the minus 4.
Isn't it?
Yes.
By 10 to the minus 4 coulombs. Yeah. You can leave the answer like that, okay? Or if you want, you can change it into like micros and millis, but don't bother, just leave it like that. Okay, what do they want next? The energy is a half CV squared, so that's a half by 8.5 times 10 to the minus 6 times 40 squared, which is 1600. So that's going to be 800 by 8.5 by 10 to the minus 6. What's that, please? 6.8 times 10 to the minus 3 joules. So in other words, it's 6.8 millijoules if you want.
If it's microfarads, it's always 10 to the minus 6.
Yes, yeah. How many marks have I gotten so far? 6, is it? 222? Yep, alright. So can I go to the next part now? So, this circuit here, 1, 2, 3, 4, and a 10 volt. Okay, so I'll just draw this here. It was 1, 2, 3, 4, whoops, and then here is 10 volts. And we'll do micros. So how big was this one? 4 microfarads, this one? 8 microfarads. 6 microfarads, and here? 2 microfarads. So we want to add these together.
No, on the.
Is that not it?
2 microfarads was the.
4862.
It was in parallel.
4862.
It was in parallel. So your diagram is wrong.
My diagram's wrong?
You had 2
Oh, thank you. The this one is only around the middle two. So it's going to there and oops, to there. Sorry about that. Here, let me make it cleaner. Okay, so do you remember your rules for adding capacitance? Which one should we add together first? Yes, very good. The 2 and the 8. Because the easy ones to add are the parallel ones. So if I add the 2 and the 8 together, what does that make?
Series.
That would be 10 here, wouldn't it? It'd be 4, 10 and 6. Because I put these two together to make... to make it, yeah. Now add these together. 1 over 4 plus 1 over 10 plus 1 over 6. What's that, please?
31 over 60.
Is 31 over 60. So then the capacitance is 60 over 31, which is 2 about 1.935, so 94 microfarads. Okay, great. So what we have now is 10 volt and then one capacitor of this big. Okay, so what does he want, or what does she want in the question? Energy. That's it. All right.
Total energy stored.
Total energy. So it's a half CV squared. So that's a half 1.94 times 10 to the minus 6. And what's the voltage? I didn't write it in here. Was it 10 volts? So that's 100. So that's 50 by 1.94 by 10 to the minus 6. What's that?
One
That's 9.7 times 10 to the power minus 5.
9.7.
Times 10 to the power minus 5.
Okay, we'll go 9.67 times 10 to the minus 5 joules. How many marks was for that? Did anyone notice?
4.
Oh yeah, so we have in total now,
8.
no, 10. 2224. So right now, I have a 10% completion of the exam. 10 out of 10 so far. Let's look at D, which is the last part. So is there time? There is. I'll give you a couple of minutes to do D now, and then I'll do it on the board. So let me just pause the video here. Okay. So I don't have the screen up there. Can you give me the information? So do they tell you the charge at the beginning, is it? Alright, so Q0 equals 350 microcoulombs?
Yes.
Yeah. And what else do they tell you? Charge at the end, 250 microcoulombs. And you're told the time is 120 seconds. And so I use my formula, Q equals Q0 E minus T over RC. Just like what you're doing in maths class, isn't it? Yeah, so here we have 250 times 10 to the minus 6 equals 350 times 10 to the minus 6 times E minus 120 over R times C. Did they give you the C? Yeah, what is it? 50 times 10 to the 10 to the minus 6. So 50 times 10 to the minus 6. I need someone just to tell me now 25 divided by 35. Okay, it's 0. Okay, and then could somebody tell me then 120 divided by this number? Minus, I want to know or divided by 50 times 10 to the minus 6, please. Just tell me what that is. 2.4 times 10 to the minus 6. Oh, plus 6, of course. 10 to the 6, 1 over or. Because the or, remember, is in the denominator. Alright, you know what to do. Log both sides. So when I put a log here and here, what do I get on the left? Minus 3369 65. Okay. Equals minus 2.4 times 10 to the 6 times 1 over or. So you get or equals 2.4 times 10 to the 6 over 0.3365. What's that?
1.7.
Say that again, Joshua?
1.714 times 10 to the minus 4.
10 minus 4?
Yeah.
No. No. 1.7?
Oh, sorry. 7.14 times 10
7 point 1413, okay, times 10 to the 6 ohms. So if you want, that's 7.14 mega ohms. Let's check the answer. Yeah.
Yes.
I think you told me soon. You said 3, didn't you?
7.13.
Okay. I'm going.
It's 1.4.
Doesn't matter. It's so not important right now. Okay, 7.13 mega ohms. Alright, what's next now? So now we want the time taken for it to decrease to 150. Okay, so this is part 2. Oh, no, don't do that. Oh, we're good. Okay, so which formula do I need there? I need this one again, isn't it? Q equals Q0, E minus T over RC. What's the Q now?
150.
150 micro, isn't it? And what's it at the beginning? Wasn't it 250? 350 micro. And then it's still the same. Oh no, we know R and C now, don't we? So if you multiply R and C, what do you get? 3, 5. So it's 0.7 then. Yes? Yeah?
3.7.
Yeah, I put in an extra decimal point. Okay, this is so easy now. What do we do? Cancel, bring this down. What do I get on the left? 150, that's 3 over 7. 375, is it? No, that's 3 over 8. What's 3 over 7? 0.41? 4286 equals E minus T over 356.7. What do we do? Log minus 0. Equals T over 356.7. Alright. Minus. What's wrong? T equals 356.7 times 0.8472, which is 0.1. If we round it off, it's 302 seconds. Which is right. Exactly right. Okay, and the last part, what is the potential difference 5 minutes later? So easy. So we want the voltage 5 minutes later. Oh, well, do we know the voltage at the beginning? It's given?
Yeah, 10.
No, you need to... Yeah, okay. So you don't know the voltage. What do we know?
The voltage is 7.
Wait, we do know the voltage. Is it given in the...
CV.
Oh yeah, so we have to find the voltage. Yes, okay. So, how do we find the voltage?
350 over 50. That's it's given. The first charge was 350.
Yeah, but it's 5 minutes later. Oh, you're finding the voltage at the start.
Yeah.
Yeah, okay, sorry. So the voltage at the start. So we use Q equals CV. We know this at the start, and we know this at the start, so we can work out the V. So V equals Q over C, which is 350 micros over 50 micros.
Yes.
Yeah.
So we get 7. So now I can use V equals V0 E T over RC. So V equals 7E. 5 minutes is 300 seconds. Isn't it 5 minutes? It's 300 seconds. And then soon,
356.
what did you say the RC was? 31.7. Okay, so when you type this in, what do you get for the voltage? Oh, sorry, thank you. That will make a big difference. What do we get? 0.
7 E
Oh yeah, just give me the final answer, it's okay. 16?
3.01.
3 point...
Yeah,
3.081.
which is 3.0.
It's 0.8.
Oh, 0. Well, let's see what we'll go for here. 3.02.
Yeah, 3.02.
3.02. So if you were to look, if you were to look at this graph here, what voltage does the capacitor start at? What did we say? 7. Yeah. And then after 5 minutes, where's the voltage?
3.0.
It's at about 3, isn't it? Now, this they did not ask. So the last part I'm going to do is just my part. But they could have asked, how long until the capacitor has fully discharged? Who remembers?
5C.
Not 5C, 5
5
tau. 5 multiply the time constant.
Oh, okay. So 5 times RC.
So the total time is 5 times R times C. Can someone just tell me what that is? What is it? Seconds. Can you just divide that by 60 to tell me how many minutes that is?
29 minutes.
29 point.
7 to
So 30 minutes.
So, how do you know what's 5 hours?
Why is it 5 RC?
Tau is RC.
Yes. The time constant is RC. So it's 5 multiplied the time constant.
Yeah, I'm not feeling about the 5.
Yeah, somebody tell them why it's 5.
Because it's approximately.
Yeah, there is. Yeah, well, you're right. There is no good reason. We use as a standard. We use 5 multiplied the time constant, but it's like a formula. There's no good reason for 5 other than it's a good approximation. This is not.
At least 4 or something.
No, you couldn't. It must be 5 because that's the convention. That's the standard to use.
It's like a formula.
It's like a formula, but it's not in the book.
So it's like a law, basically.
It's like a law that it will take 5 multiplied the time constant time to discharge.
So like Avogadro's number or whatever.
It's like Avogadro's number. It's like a constant. It's 5 time constants. But you know, there's no good reason to choose 5. The rule could have been 6 or 4. It's just 5 is what we use as the best estimate for most problems, most little circuit problems, okay? But as soon as you start dealing with huge capacitors and huge voltages, this no longer makes any sense, okay? So for this 5 rule, we're always talking about small voltages, small currents, not big power stations, okay?
So is that 30 minutes or 38 minutes?
30 minutes is the time it will take this capacitor to fully discharge to 0 volts. After 30 minutes, the capacitor is fully discharged. Yeah. I expected the answer to be more than 5, of course. Why? Well, because it takes 5 minutes to get to 3 volts. So it should take much longer than to get to 0 volts. Now, how long did it take us to do that one? I think about 20 minutes?
Yes.
Because I stopped to let you try it first, yeah.
No, probably would be like 10 minutes.
I think if nobody was talking, if you just had this in front of you, no, what I mean is if you had it in front of you by yourself in the library and you were just doing it, 10 minutes maybe, 15 minutes. Now that was a full section B question.
20 marks.
20 marks, 20% of the exam. Alright, so this is why I like the electricity question in the exam. I like it. Because it can be really, really nice. This one was really, really nice. Like if you saw that question in the exam, that is a gift to you. It is a present. Isn't it? Wouldn't you agree? Good. We'll talk more about the exam later in the semester, okay? But what I'm going to do is, I'll tell you what my plan to do is, on Moodle, I'm going to make a table. And it will say 2013, 2012, like this. And then what you have here is A1, A2, etc. B1, B2, etc. And my goal is each one of these will be links. You click them and watch the video. So for example, what year is this? 2013?
2013.
B6. So today I'll upload 2013 B6, and when you click that, it gives you this video. Now I don't think there'll be enough time to do all the questions. I'll try my best in class, But this way, it makes it easier for you to do revision. When you have the exam and you don't know how to do a question, you just click the button and you get the video for it. Okay? But like I said, I'll probably only get half the table done. So I'll focus on maybe the most important questions. The section B's, I think, because they're big questions. The section A's, you might be okay with yourself. They're short questions. Alright? Sounds good? You seem excited and hungry. Okay. Alright, we'll leave it there, so.